Chapter 9 is all about probability. So a lot of vocabulary here. An experiment is an activity in which results are observed. A trial is each observation of an experiment. So an experiment could be flipping a coin 10 times. Each time you flip the coin is a trial. An outcome is the result of a trial. So if we're flipping a coin, we're probably talking about heads or tails, for example. If we were rolling a die, it would be 1, 2, 3, 4, 5, and 6, assuming it's a standard 6-sided die. The sample space is the set of all possible outcomes of an experiment. So if you're flipping a coin, your sample space is heads and tails. If you're rolling a die, your sample space is the set 1, 2, 3, 4, 5, 6. An event is any set of one or more outcomes. Probability. Written P parenthesis event close parenthesis. It is a number between 0 and 1, 0% and 100%, that describe how likely the event is to happen. So if we were flipping a coin, I might say the P heads in the shorthand notation would be the probability of flipping heads, and that's 50%. That's 50%, 0.5, or 1/2. All three forms are equivalent, and I don't particularly care which ones you use. Impossible is an event that cannot happen. The probability of such an event is 0. The probability of school starting in July is 0, never going to happen. An event which must happen, on the other hand, has a probability of 1, and it's called certain. Christmas is on December 25th. That has a probability of 1. It's true. So, examples. The weather forecast calls for a 40% chance of rain. What is P rain? So the probability of rain is the 40%. What is P no rain? Well, there's only two possibilities. It's going to rain or it's not going to rain. So if there's a 40% chance it will rain, that means there must be a 60% chance that it won't. Probabilities must add up to 100%. If they don't, something got really weird. A spinner has 4 colored sections of equal size. 2 of them are red, 1 of them is yellow, and 1 is blue. What is the probability of red, the probability of yellow, and the probability of blue? Well, the probability of red, there are 2 red sections and 4 total sections. So the probability of red is 1/2, which you could give as 50%. Again, equivalent forms, I don't care. There's 1 yellow section, so the probability of yellow, there's 1 yellow section. That didn't change to yellow. Let me change that again. There's 1 yellow section. There are 4 total sections. So the probability of yellow is 1/4, which is also 25%. And the probability of blue, P blue, probability of blue. There is 1 blue section. There are 4 total sections, so 1 in 4 chances of blue. So it's also 1/4, which is still 25%. A quiz contains 5 multiple choice questions. Supposing you guess randomly for each question. This table gives the probability of getting these scores. So the probability of getting none correct is about 23.7%. The probability of getting only 1 correct is about 39.6%, and so on and so on and so on. The probability of getting all 5 correct is 1/10 of 1%. So what is P 1 or more correct? Well, 1 or more is all of this. So the probability of 1 or more correct means I've got to take 0.396. I'm not going to write this out. I'm not going to have room. What we need to do is we need to add all 5 of those. we are going to add P1 dot 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 up through P5. We're going to add all of those. So 0.396 plus 0.264 plus 0.088 plus 0.014 plus 0.001. When you add all that up with your handy-dandy calculator device, which you are allowed to use, you get 0.763. And you can leave it like that, or you can rewrite it as 76.3%. Probability of getting fewer than 2 correct. Well, fewer than 2 doesn't include 2, it means less than 2. So we're talking these two now. So fewer than 2 correct would be adding the probability of getting none correct and the probability of getting 1 correct. So we're going to do 0.237 plus 0.396. And here the probability is 0.633. And the probability of passing. Okay, now this one. A passing score is anything for us that is 70% or above. On a 5-question quiz, each correct question would be 20%. So 0 is 0, 1 is 20, 2 is 40, 3 is 60. Those are all failing grades. 4 would be 80%, and 5 would be 100%. So those are your passing grades. So to pass, you have to either score 4 or 5. So we're going to add P4 and P5. And when we do that, there's 0.015. Last example for this section. 6 students remain in a spelling bee. Amy's probability of winning is 1/3. Amy is twice as likely to win as Kim. Bob has the same chances as Kim. Pat, Annie, and Joe all have the same chance of winning. Create a table of probabilities for this sample space. Okay, so we've got Amy, Kim, Bob, Pat, Annie, and Joe. We know Amy has a 1/3 probability of winning. We know Kim has half of Amy's chance of winning. Well, what's half of a third? Half of a third is 1/6. You would do 1/3 times 1/2. So Kim has a 1/6 chance of winning. We know that Bob is equal to Kim, so we can give him 1/6 now as well. What we don't know are these last 3. So I'm temporarily going to say that they have X probability of winning. Now, I told you before the probabilities must add up to 100%. When dealing with fractions, that means they have to add up to 1. So what I'm saying here is we have this 1/3 for Amy, and 1/6 for Kim, and 1/6 for Bob, and these 3 X's, so 3X. If I add all those up, I have to get 1. Well, okay, how does this help me? Well, 1/3 plus 1/6 plus 1/6 is 2/3. One-third is 2/6. 2 plus 1 plus 1 is 4/6. 4/6 is 2/3. That's how I did that. You can also use a calculator right now. You have to think way, way, way back now We did cover how to solve two-step equations back in like chapter 2, maybe? What you need to do is subtract 2/3 from both sides, which, give me a second, I forgot I'm on the edge of a page here. It's not going to like that. Whoops, didn't mean to get rid of that. Let's put that back. That's not an X. My iPad is messing with me. Give me a second. We're fixed. We are going to subtract 2/3 from each side. That's going to get us 3x equals 1/3. 1 take away 2/3 is 1/3. Now we can divide both sides by 3. So if 3x equals 1/3, if I divide both sides by 3, x is 1/9. Don't know when I lost all of this. So now I know instead of x, x is 1/9. So Pat, Annie, and Joe all have a 1/9 chance of winning.